Hello, everyone. Once again, you are welcome to today's lesson. And in today's lesson, we are going to look at a new topic. And just as you have on your screens, the topic is going to be quadratic equations. And this topic, you are not new to it. It's something that you did in JHS. So we are going to consolidate your understanding, whatever that you learned in JHS. Okay, going forward. But quickly, before I introduce you to this topic, let's go and look at our lesson objective. Okay, so the learning objective, as a result of studying this topic, the student will be able to, one, understand what a quadratic equation is and its associated concepts. Then, so what you have here will basically be, the first one will be your general objective. Okay, so it means it will encompass all that we are going to have below it. Okay, so let's look at the next one. Define and identify a quadratic equation. Solve quadratic equation by the factorization method. Solve quadratic equation using the quadratic formula. Solve quadratic equation by the method of completing the square. Then define and identify a perfect square trinomial. Okay, then find the last term of a perfect square trinomial. Then factorize a perfect square trinomial. The last three that you have here, if you know how to do that perfectly, then this, particular objective just before the last three, we can easily deal with it. So what we have here is supposed to help us, solve quadratic equation by the method of completing of squares. Okay, it's not arranging any particular order, but these are the objectives. As and when we attain any of the objectives, we can take. Okay, so we check what we have there. Okay, however, before I introduce you to it, let me see if I can stimulate recall of previous knowledge. If I may ask at this point, in JHS, when you were introduced to quadratic equation, what were you told, that a quadratic equation is? In effect, how do you identify quadratic equation? Because if you know, what a quadratic equation is by way of definition, then you should know how to use the definition to identify such. Okay, so what is a quadratic equation? You can try. Please try. Don't be, or I will call you one after the other to tell me your own version, how you understand what a quadratic equation is. Okay, so Prof. Mamisa, set the ball rolling. What is a quadratic equation?
I think a quadratic equation is a formula in which it has a number that is squared with a variable associated with a coefficient, and lastly, a constant. So we have to use that formula to find it.
Okay, it's a good try. At least, it goes to establish the point that you have an idea. Only that you couldn't put everything together to come out the way I want it to come out. But that's a fair try. Okay, no issues at all. I will ship, whatever that you said pretty soon. Okay, so Prof. Kojo. Prof. Kojo, are you there?
Yes, sir.
Your version of quadratic equation.
Uh, it's an equation that has a certain degree in x.
That has a certain degree. Is that what I heard?
Yeah.
I don't know whether it's your
Sir.
network. Come again.
Sir.
I'm waiting. In fact, we are waiting. Prof. Kojo, please come again.
It's an equation that like
That
has a second degree in x.
a second degree in x. Okay, what is meant by a second degree in x?
Like uh, a square of x.
A square of x. Okay, great. All right, so you've all done well. Okay, keep it up. Okay, only that, Prof. Mamisa, remember, you said a square of a constant. Is that not it? I heard a square of a constant. I hope I heard you right.
Yes, sir.
Okay, so it shouldn't be a square of a constant. The square should be on the variable, not the constant. Okay, so that's made whatever that you said there not very useful because of that statement. Okay, so quickly let me walk you through, but you've done well. Okay, so far. So let's see. Okay, what I have here by way of a definition. So a quadratic equation in variable x. So a quadratic equation will always be in one variable. Okay, it's an equation in the form as squared plus bs plus c. And here, because it's in variable s, that's why it is x. If it's variable y, then it will be ay squared. Okay, so your x here is a variable indirectly, where a, b, and c are constant. So once you bring out what the variable, you identify the variable, the rest will always be constant. However, okay, there is a particular condition that must be attached, which was lacking in, I should say, but for that condition, Prof. Kojo's answer would have been the best, okay, to go for. Okay, so here, this condition is very vital. Your A should not be equal to 0. So all the constants here, all the A, B, and C are constants. Okay, and constant means they will take numerical values. Okay, however, B can take 0, C can take 0, and any other constant, but A cannot take 0. Immediately A is 0, you see that this term will go. Do you agree with me? If A is
Yeah.
0, this term will go, and it is this term that is making the equation here quadratic because of the power. So immediately that term goes, it means what we have there is not a quadratic equation. Okay, so the s term can go, the constant term can go, the 2 can go, and you still, if this is left, okay, you still have a quadratic equation. So I can have a quadratic equation, okay, which will have no linear term, which is the term in x, which will have no constant term, which is the term here. Okay, or it will be devoid of a linear term and a constant term. It is still quadratic because I have a variable x, okay, and the power of the variable x is what? 2. Okay, so example, s squared plus 2x minus 3 is equal to 0. 3s squared minus 5x minus 2 is equal to 0. Okay, etc. Okay, note, like Prof. Kojo said, a quadratic equation is also known as a second degree equation. Okay, the degree of any polynomial, okay, is the highest power of the variable involved. So here, the variable here is x. Okay, the x here, the power is 2. The power here is 1. Here there is x there, only that usually we don't write it, s to the power 0. So it's 2, 1, 0. Okay, so the highest power of what? Your variable here is 2, making it second degree. If the highest power is 3, it will be third degree. If the highest power is 4, it will be fourth degree. If the highest power is 1, okay, then it will be first degree, which will be the linear equation. 3 will be cubic equation. However, today we are restricting whatever that we are doing on, okay, the power 2, which is the second degree. Is the concept, the explanation of the definition and the concept, okay, clear?
Yes, sir.
Prof. Mamisa, are you fine?
Yes, please.
Okay, so never define without, okay, attaching this. This is very critical. No matter how long you write, if this is not there, okay, you know, you won't get the full score. So now that we know the definition, let's see if you can identify, okay, equations of that nature. So which of the following equations, okay, represents a quadratic what equation? I think you should be represent. Okay, but it's okay. So now let's see. Okay, the first one, A. Let's see. Is this a quadratic equation? So we are looking at the solution. This one we are revising. Okay, so A. Given, what are we giving? Okay, you can choose not to even write this one. Let's go straight away to the answers. We shouldn't let this waste our time. Okay, so A, is it or is not? Is this a quadratic equation?
Yes, sir, it is.
Okay, so it's a quadratic equation. Or you can write quadratic equation. Hey, Okay, all right, forgive me. I'm in a hurry. Okay, so my hand was faster than my. Okay, so. All right, so let's come to the B. Is it also a quadratic equation?
No.
Okay, why?
Because
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 Am I allowed?
Mami sir, you say your answer, then I'll come to Prof. Kojo. Give me a reason. You said that it is not. What is your reason? I want to know whether it wasn't a guesswork.
the thesis said that the quadratic equations is where the A, B, and C are constants and A is equal to 0. So in this case, it's supposed to be
And
a
what
fixed.
and what is not, what is equal to 0?
A is not equal to 0.
Okay.
When we come down, we see that the formula here is not the one that has been given to us
Okay.
because it's
Okay, not to cut you, forgive me. This is not, I should have addressed that. This is not a formula. Okay, this is an equation. A formula is different from an equation. A formula is a relation. Okay, where you see something, a letter is equal to other, okay, letters or other relations. Okay, a variable is related to other variables in a particular or constant in a particular way. So this is an equation, not a formula. Okay, so use your words carefully so that you speak the correct math language. Okay. All right. Okay, so I get your point. Your point is well made. Now let's see, then I will come in. Prof. Kojo, what's your answer and your reason?
So with the quadratic equation,
Is it first before you give your reason?
so no, it's not. It's not.
Okay. So you agree with Prof. Mamisa?
Yes, sir.
Okay. Your reason?
As you said, it shouldn't be with anything that is not 0 or less than. So,
As I said.
no, as she said.
As she said. Okay, it's good you said as she said. Other than that, you would have heard from my lawyers. Because I have I have never said that. All right. Okay, so this is it. Unfortunately, your answers were wrong. You see, every equation that you have, is this an equation? Is this an equation? Is
Yes,
it?
sir.
It is. Do you agree? Do you all agree that this is an equation?
Yes, sir.
Okay, so remember, for you to identify quadratic equation, it is the power of the variable. First of all, look for the variable. Okay, then go for the power of the variable. If the highest power of the variable is 2, okay, then it means what you have there is a quadratic equation. It doesn't really matter the arrangement of the terms. Okay, in any case, can't we move this one to this side so that it will be of this form? We can. Is that not it? It's mathematically right to move this one to this side. Because anytime you have an equation, you have left-hand side, right-hand side. Whenever you have left-hand side, right-hand side, we can always move either terms from left to right or right to left. So it doesn't really matter the places, okay, or the size that you have your terms. What is important is the variable and the highest power of the variable. So here the variable is x. The highest power of the variable is what? Is 2. So that will make this a quadratic equation. Please, is my point well made, my professors?
Yes, sir.
Okay, so this is quadratic, only that it's not in the standard form where everything is on one side equated to 0. Is my point well made?
Yes, sir.
Okay, so B, quadratic. Okay, so let me do this. You cannot do this. Take notes. Okay, so C. Okay, so let's see. Let's see whether the C is what? Is quadratic or not. Think through. I'm giving you about 10 seconds to think through based on the information that I just gave you. Okay, so Prof. Mamisa, is it quadratic?
No, please.
Okay, why?
Because the first one doesn't have the power of 2, so it
Okay,
doesn't.
very good. Perfect. Okay, the x has a power of 1. So what would this be? If it's not quadratic, it's a form of equation that you are familiar with. Okay, what equation would this be?
Linear equation.
Linear equation. Perfect. So, or equation of what degree? Remember, if the power is 2, it's second degree. So if the power is, it will be first degree. You get the point?
Yes, please.
Okay, very good. All right. Prof. Kojo, do you agree?
Yes, sir.
Okay, so now this one, I'll start from you. Okay, is this quadratic or not?
It's not.
It's not. Why?
Because it has it doesn't have a power of 2.
Okay, the power is more than what? 2, which is what? 3. So it should be, the power should be exactly equal to 2, less than or greater than 2. No, you can't take it. Okay, so looking at what you have, the degree is 3. Sorry, I have answered. Okay, anyway, the power is 3. Okay, what will be the name, the special name given to this as well?
There's a third degree.
Third degree. But usually, okay, instead of saying third degree, if you want to use degree, we can say degree 3, we can say third degree. But we can also say that this is a cubic equation. Linear equation, quadratic equation, then cubic equation. Is my point well made?
Yes, sir.
Okay, so it means we said the C was not. So not. Okay, D. Okay, also not. Okay, as for this one, the last two, I won't write it. Okay, you just say it, then we are good to go. So the E, is it? The whole class?
Yes, sir. It is.
Yes, please.
It is. The variable is x and the highest power is 2. You don't see a linear term, a term in x. But remember, I've told you, once you don't see a term in x, then it means the coefficient of your x here was negative. That's why there is no term. So was 0, forgive me. Was 0. That was why there is no term in x. However, b can be 0, is allowed. What will make this quadratic is the x and the power. Okay, any other Mason term, you are not interested. Okay, so here, constant term. This one too, it is. Is it? Is it
Yes, sir.
quadratic? It is. Okay, so now we know the definition of quadratic equations and how to identify such. Okay, now let's go and look at whatever that. But before we move on, any questions?
So if this is a quadratic,
It seems your line is bad. I didn't hear the latter part of your statement or a question. Come again, Prof. Mamisa.
sir, please, no, it's okay.
You were asking a question. Oh, you are fine.
Yes, please.
Okay, great. Prof. Kojo, are you also fine? Can I move on?
Yes, sir.
Okay, all right. So if that's the case, then let's move on to, okay, and we are going to look at this. In fact, quadratic equation, so we are going to look at method of solving quadratic equation. A quadratic equation can be solved by either of the following methods. Okay, and I should have asked you anyway, but okay, no problem. I have said the first method, so maybe I will ask you to mention the other method if you know any. Okay, so the first one, A, okay, by the method of factorization. So this will be one of the methods that we can use in solving quadratic equation. Okay, any other method that you can mention? Any other method? Look at the late Prof. Judah. Prof. Judah, any other method? When did you join? Because I checked some few minutes ago, you were not with us.
Sir.
I guess you just joined.
Yes, sir.
And you are trying to announce your presence. Go ahead.
Sir, please, the quadratic formula.
By the quadratic formula. Very good. Okay, any other? So thanks for making your JHS teacher proud. Any other method?
Completing the square.
Completing of square, very good. So in JHS, okay, usually, I don't know whether completing of squares you were taught in JHS, because our time, that wasn't part of what the syllabus. Okay, so we were supposed to, or the method that we were supposed to have been taken through were the factorization method and the quadratic formula. Okay, completing of squares is really for SHS. So we'll look at that. Okay, that's where I will spend most of my time. Okay, so quickly, let's look at the steps that we have to adapt. I know you know, but you know we are revising. I've told you at a point we revise, and I will tell you the matured way, the ideal way to present your solution as well. Okay, so steps. Step 1, write the equation in the standard form. And remember, I made use of the standard form where I said the standard form of a quadratic equation is where you have everything on one side equated to 0. So you should have 0 on the other side. And that was what, okay, initially we're using to identify what a quadratic equation or not. Okay, and I said it shouldn't necessarily be in the standard form. There's the power of the x that you use, the highest power of your variable involved. Okay, so everything is, so first of all, make sure that your equation is in this form. So if you have some terms on the other side, or the other side is not 0, make sure you move everything to one side to make it 0. And again, not only that, if possible, make sure the coefficient of your s squared, which is your leading coefficient, is positive. Okay, so after moving, whenever you are moving, make sure that your first term is positive. Okay, we'll get there. But for now, move everything to one side equated to 0. Then 2, factorize the quadratic expression completely. So this is the quadratic expression, okay, and we will factorize what we have here completely if you know the technique in solving quadratic equations. Then 3, okay, using the zero product rule or property, set each of the factors to 0. So you factorize every quadratic expression, if factorable, will factorize into 2 linear factors. Okay, so you set each of the linear factors to 0, then you solve each of the linear equation. So please take notes. And look at this. This information is very critical. A quadratic expression as squared plus bx, and this is the quadratic expression here, is out of every equation contains an expression. Okay, so expression that you equate to 0, that will give you an equation. Okay, so quadratic expression as squared plus bx plus c, where again a is not equal to 0, is factorable if and only if its discriminants, and by that we mean, when we say discriminant, we mean b squared minus 4ac. So you know your a is the coefficient of s squared, b is the coefficient of x, and c is what? The coefficient of s to the power 0, which is your constant term there. Okay, it's a perfect square. So if the value of b squared minus 4ac is a perfect square, then it means your quadratic expression is factorable. Once it's factorable, then it means you can solve by the method of factorization. So if b squared minus 4ac, your discriminant, is not a perfect square, then it means you cannot factorize. Therefore, you cannot, once you can't factorize the quadratic expression, it means you cannot use the method of factorization, because the method of factorization is pinned, okay, on you being able to factorize a quadratic expression. So if the quadratic expression is not factorable, then it means you cannot use the method of factorization. Is my point well made?
Yes, sir.
Okay, great. All right. So if that's the case, let's go and look at some worked examples. Okay, so quickly, okay, our first worked example. And this one, okay, is something that we've been, okay, so this is what we are going to do. Here we are going to look at our first work. Then the first worked example, I won't spend more time on it because we've been using the method of factorization to solve a lot of questions that resulted in quadratic equations. So maybe I will do maximum 3 just to let you know the various ways, okay, or deal with the various situations. Okay, then after that we'll go to the next what method. Okay, am I clear, my professors?
Yes.